In today's lesson, we are building on what we did in lesson 8 and doing more about equations of lines and how we graph them, just so that we get more practice. So first thing I want us to think about is how can we just look at an equation and figure out whether it is a line or something else. And so we look at these, and the first thing that jumps out at me is, oh, wait a minute, this one has an x squared in it. And I remember that lines are y equals mx plus b, and there's nothing about an x squared in there. So x squared plus 3 equals 5 can't be a line. It will end up being one of those U-shaped parabolas if we had it as y equals something with an x squared in it. And so then I look at these two over here on the left, and oh, I could get each of those as 2y equals something, and then I could divide everything by 2, and yeah, I'd have a y equals mx plus b. Or another way of saying that, I look at them and I have an x and a y, and they both have an exponent of 1. They are both first degree, so I know that those have to be linear equations. Now, y equals 0 is a little bit puzzling because I don't see an x in there, but it is actually a special line. It is actually y equals 0x plus 0. It is the line that goes through 0, 0 for the y-intercept with a slope of 0, so it's a horizontal line. And in general, y equals any number is always a horizontal line. So that helps us think a little bit about some special cases. You are going to have a lot of problems where we give you an equation. You must write it in y equals mx plus b form in your box. This one is already like that. There will be quite a few where we say, what is the slope? What is the y-intercept? What is the x-intercept? So for the slope, y equals mx plus b. M is the slope, so the slope is -2. It is wrong if you say -2x. The x is not part of the slope. It is part of the equation. If we wanted to graph this one, I know that the y-intercept needs to be that b. That means it is on the y-axis, 1, 2, 3, 4. When you write it in the problem set box, I need parentheses and a comma, and I need the 0 in there. This one was across 0 and up to +4. If the slope is -2, that means I need to go in the downhill direction. And if I get myself a little bit confused, that is -2 over 1. It is not -2 over -2. So it is up and down 2 and across 1 so that it tilts downhill. So for this one, I will have a line that ends up looking something like this on my graph. The x-intercept is then where it crosses the x-axis, so it is this point. I can look at the graph and I know I go across to something and I go up and down 0. So x-intercept always has y equals 0 for the second coordinate. Both of those must be written as ordered pairs. To find the x-intercept, the y-coordinate I know is 0. So I simply let y equals 0 in my equation. So 0 equals -2x plus 4. And I need to then solve that to get what x is. So 2x equals 4. If I take the minus 2x to the other side, it changes from negative to positive. Divide both sides by 2, and x is 2. So I fill in that my x-intercept is a 2 on there. This one, you could have figured it out by counting dots. When you went down 2 and over 1, you landed exactly on a lattice point right on one of the grid points there. But sometimes it's not going to be that easy to count your boxes and get there. Okay, that one gave us the equation and we needed the line. If we start with the line, what can we figure out? Can we figure out enough that we can get an equation? So I look at this one, and one of the things I see is I think it goes through 0, 2 for the y-intercept, but it doesn't have a dot on it. I see these purple dots right here and right here, and that means, yes, those go exactly through the corners, and they give me the coordinates of those points. They don't give me a dot on that 2, so maybe it's really 0, 2.0004. Maybe it's not quite 2, so I want to be careful as I do this. So first thing I notice is my slope is negative because my line goes downhill. Since I have 2 points, I could use my formula that we learned the other day, or on this one I could simply count boxes, 1, 2, 3, 4, up and down, and 1, 2, 3, and another 1, 2, 3 for a total of 6 going across. So my slope is going to be negative 4 over 6, which I would reduce to negative 2 over 3. So I know that I have y equals negative 2/3 x plus b. I think b's 2, but I'm not quite sure. So I'm going to pick one of the points that I know and plug it in. I could plug in negative 3 for x and 4 for y, since I know negative 3, 4 right here on the graph. I could do that, it's not too bad. But if I pick this point, 3, 0, and plug it in, hey, that's easier math to do. If x is 3 and y is 0, then I simply have 0 is negative 2/3 times 3 plus b. So 0 is negative 2 plus b, and if I add that 2 to both sides, yep, it looked like that to me. b is actually 2, so I can say my y-intercept is 0, 2. I can say my equation is y equals negative 2/3 x plus 2. And I can say I already know my x-intercept because they labeled it here, that my x-intercept is 3, 0. So I could get all of those same things if I start with the line and know 2 points on the line. Okay, this one's a little bit of a special case. 5y equals 20. Divide both sides by 5, and I have y equals 4. And that's all I have. That says y is 4 no matter what x is. So x could be 2 and y is 4. X could be 7 and y is 4. X could be 0 and y is 4. X could be negative 4 and y is positive 4. And I quickly see, oh, y is always 4 no matter what happens with the x, simply means that we have a horizontal line. So in this case, we have a horizontal line. It was y equals a number, as I said on an earlier slide. I can say that my y-intercept is x is 0, y is 4. It never crosses the x-axis, so I can say there is no x-intercept. And I can say that the slope equals 0. It is flat. I could also write this as y equals mx plus b, just to convince myself this is equivalent. Y is 0x plus 4. That is the same thing as y equals 4, which is the equation that I was given to begin with. So y equals a number, horizontal line with that y-intercept. Another special case. This time 2x equals 5. So this time I don't have a y in there, so I divide by 2, and I say x is 5/2 or 2.5, whichever way you like to think about it. That says no matter what y is, x is always 2.5. If y is 0, if I haven't gone up or down, x is 2.5. If y is 4, x is 2.5. If y is 10, x is 2.5. If y is -5, x is positive 2.5. So I look at that and I see these line up and give me a vertical line. So I can draw my vertical line going through those. So it's just a little bit better. So that one, we say, well, first of all, we just said, I'll write it down, that it is a vertical line when we have x equals a number. We see that that one has no y-intercept, and we see that the x-intercept is 2.5, whatever that number was, x equals the number, comma 0. And for this one, we say that the slope is undefined. To make a little bit of sense out of that, I'm going to pick 2 points on there and try to use my slope formula on that. So let's suppose I pick 2.53 and I pick 2.51. If I try to do my slope, the vertical distance between them is 2, but the horizontal distance between them is 0. And I can't divide by 0. So that's why we get that the slope is undefined. It's not equal to 0, it's undefined. Another thing about a vertical line, and we'll review more of this later, a vertical line is not a function. And we won't worry too much about that today, but I just want to plant that seed. We did a little bit with functions last year, and we'll do some more several lessons down the road. The book is going to give you a number of problems where they put 2 or 3 lines in the same graph and ask you for the equations. Pay attention, they label them A, B, and C, and so I want you to do them and label your work A, B, and C. So A is a vertical line. Vertical lines, that was always, was that the x equal or y equals? Let me see. Oh, for that one, no matter where I am, the x is always -3. So I can simply say that one is x equals -3. It's vertical, so the slope is undefined. It does not cross the y-axis, so there is no y-intercept. The x-intercept is -3, comma 0, this point right here where it crosses the x-axis. Let's take a look at B next. That one has a positive slope. And let's see, as we look at that one, it goes through 0, 3. And we also have this point right here that it goes through. So it has a positive slope. And it goes up and down 1. And it goes across 3. So positive 1/3. So I can say on this one that y needs to be mx plus b 1/3 x plus my y-intercept right here was 0, 3, so plus 3. Because my direction said the equation, the slope, and both intercepts, I also write down that the slope is positive 1/3. The y-intercept is 0, 3, and I need to get the x-intercept. I think it's -9 over here, but I could plug in, just to be sure, if y is 0 equals 1/3 x plus 3, subtract 3 on both sides, y is 1/3 times x, multiply both sides by 3, yes, x is -9, so I can say my y-intercept is -9, 0. And that leaves my horizontal one, which is labeled C. And let's see, for C, I know horizontal lines had to just be y equals. As I look at that, no matter where I am on that line, the y coordinate is always -7. So that is my equation. My slope is 0 because it's a flat horizontal line. My y-intercept is 0, -7, this point right here. And there is no x-intercept. And another one, just to review, let's do one where we have to do the whole thing. We have the equation, but we need to get it in slope-intercept form. The first example already was in slope-intercept form. This one isn't. You must always get the y equals form of the equation and write that in your box. So this needs to be 3y is -2x plus 3. I'm trying to get y by itself, so I keep the 3y, but I move the 2x to the other side and make it negative. Since I want 1y, I need to divide everything by 3. So I'm dividing the -2x by 3 and the 3 by 3. So I have y is -2/3 x plus 1. That's one of the things that you're required to have in simplified form in your box. Then we can say that the slope is -2/3. We can say that the y-intercept is 1, except we have to write that as an ordered pair. So that means on the y-axis we go to 1, so that point is 0, 1. And our x-intercept we need to find. It's got to be something 0. So I can take somewhere in my equation and let y be 0. I could go to this one with a fraction -2/3 x plus 1 and say 0 equals that. But I think it's going to be easier to take my original 2x plus 3y equals 0 and say that is 2x plus 3 times, let the y be 0, equals 3. So 2x plus 0 goes away, divide both sides by 2, and I get that my x needs to be 3/2 or 1.5, whichever way you would rather think about that. That tells me that on the x-axis, I also go through 1.5, 0. I could line my straight edge up through that, but it's awfully difficult to get it tilted exactly right when points are that close. So I still want you to use your method of drawing dots all the way to the edges to get your whole line. So we are going to go back to our equation of the line. Y is -2/3 x plus 1. We are going to start at our y-intercept. We are going to say, oh, we need to go in the negative direction. So we have a negative slope. It needs to tilt downhill. And if our slope is -2/3, that means up and down 2 and over 3. So I'm going to come up and down 2 and over 3. Up and down 2 and over 3. Up and down 2 and over 3. Then I'd be off the grid. Go back the other way. Up and down 2 and over 3. Continuing so it slants downhill. Up and down 2 and over 3. Up and down 2 and over 3. Then when I've gone as far as I can, with plotting points. Then I draw my line going through all of those points that I have just sketched. And make sure that you remember to put the arrows on both ends. Mine are there, but I'll make them a little bit bigger just for emphasis. And that finishes our review, and now it is time to get on to you trying to do some of the problems.